Hello everyone and welcome. In this lecture we'll be improving our unit spawners. We see here that this player has 2 over here and the other player has 2 over there, and I can click on them maybe twice or 3 times. It'll cost me some resources and it'll produce some units, and when they're ready they'll pop out and the number will go down to reflect how many are in queue. And I can come over here and do the same. I've set the max to be 5, so I can't have more than 5 at once, but as soon as it is ready I can click to spawn in a new one, and then my tanks are made. It looks, they keep getting stuck as they all try and fight over the same space because they're so big on such a small map. So in the next couple of lectures, we'll be making the map a lot bigger, spreading the players out and adding camera controls and a minimap. So yeah, let's get started with improving the unit spawners. So now we want to upgrade our current unit spawners because right now we just spam click on them and they produce units immediately with no cost. So we need to add a price to our units, a time to produce, and a max queue, so we can have, let's say, 5 or 10 being produced at once, and then a duration of that queue, how long it takes to make a particular type of unit. So to do this, we'll start off with some UI. If we head over to our prefabs, go over to the unit spawner, we currently have this. I want to make some UI above this that will display how many units are currently in queue and how long it is till the next one's ready. So if we make a new canvas on here, right click, new UI canvas, we've done this plenty of times now, and we want to rename this to be the unit spawning canvas. And it should be a bit of world space UI as opposed to screen space. So let's change to world space, get rid of the scaler, and get rid of the graphic raycaster because we're not going to be clicking on this. And as for positioning, let's set it to a position of 0 and 2, so it's up here, and a width of 1 and 1. Then the health bar canvas right now is also in the middle of this. So let's move the health bar canvas down to 1.25 and then turn it back off so that it's not overlapping the other bit of UI. So we don't want to spend too long on the UI, we want to focus on getting it to work. So let's simply make a new image, and this can be the background, so let's rename it background. And we will change it to be some kind of dark grey color. And we'll also click on the anchors, hit Alt and stretch to fit the parent. We also want this to be a circle, so let's select a sprite and the circle sprite, and then tick use sprite mesh. We then want any children to also be this circle or smaller to stop it overflowing out the edges. So we can add on a mask component, and that will do that for us. Because if we now add a UI image, it's normally a square, but you'll see it actually adds it as a circle. And we want this circle to be able to fill and unfill. So what we want to do is select a circle for this and change this from simple to filled, and we won't be able to see it if it's the same color, so let's make it some kind of yellowy color. And then now if I was to change the fill amount, you actually see it filling up and down, but the origin is currently at the bottom, so let's flip this to the top, and there you go. Now because of the mask, I don't have to worry about this too much, but I will hit the anchors and also scale to stretch. We'll rename this the timer image. And then we want to make some foregrounds to this because it looks weird just being a big circle. So we'll add to the canvas another UI image. And we'll call this the foreground. It'll be a stretch to fill, Alt bottom right. It's going to be a circle again. It's going to use sprite mesh, and then we just want this to be a bit smaller, so let's add in a padding of 0.1, not on Z, and then 0.1. We then want some text on here, so let's right click UI text mesh pro, and for some reason it didn't go as a child, so let's drag that on, and we'll call this the remaining units text. We also want this text to stretch, so let's hit Alt bottom right, and we'll give it a padding of, well, we'll leave it at 0, it's fine. We need to make sure the size is correct, because right now it's 36, which is huge. So let's just hit auto size and put the min to be really small, because this UI is really small. We'll type in, let's say, the number 0 as our current text, and we'll change the color so we can actually see it to be black. The final thing is to align it, so let's hit center and center. And now we're done with this. But let's make the timer image fill be empty by default, so it looks like this, and we can write code to change that. We also want this canvas to be a prefab that we can use in other bits of in other unit spawners. So let's take it and add it to our project, like so. And now it's a prefab, and we can go and write some code. Let's go to the unit spawner, and we have the unit spawner script. and we can open that up and make our changes. Currently we have this, and we have reference to all of these different things. And what we want to do is we want to be able to read the actual price of our unit. And currently we reference it as a game object, but instead let's reference it as a unit. So we'll call this the unit prefab. And then we also want to give units, if we open the unit script up, we want to give them some kind of price or resource cost, because currently we don't have that. So we'll make a new serialized field, private int resource cost equals, let's say 10 by default, 10 resources to produce this unit. And then down here with the getters, we'll make a new public int get resource cost that returns the resource cost. Back into the unit spawner, we need to add a few more things. So we need reference to those UI elements. We need reference to some text, so tmp underscore text, and we'll call it the remaining units text. And if we go back over, it'll ask us to import tmpro. We then also want the image that we want to fill in, so serialized field private image, and we'll call this the unit progress image. Let's import unityengine.ui. We then need some settings, so serialized field private int the max unit queue. So how many are we allowed to queue at once? We'll say 5. We then want the range at which they move, because when a unit spawns in, it won't just stay at that one spot. It should move somewhere nearby so they don't all stack on top of each other. So we'll say float spawn move range equals maybe 10. I think 10's a bit big, so let's go for something like 7. And then we want to add one more thing, so serialized field private, and how long it takes to make a unit, so float unit spawn duration equals, let's say, 5f. We then want some sync vars. So what do we need to sync? Well, we need clients to be told how many units are in queue. So let's make a private int queued units, and also how long is left until the next unit is ready. So a private float unit timer. And these are sync vars, like I said, so we'll add the sync var component or attribute. And that means it's time for your challenge, which is to sync the queued units and update the UI. So I'd like you to create a private int variable to store the number of units, which we've just done. Make it a sync var, which we've just done. And then make a callback method for it, so something like client handle queued units updated. And that should be used as the hook for the sync var. We've done this before. I'd like you to assign this method as the hook. And then in that method you make, so the handle queued units updated, write some logic to update the actual text to display the new number of queued units. So the server will handle changing the variable, and then when the clients are synced the variable and they're told the new value is 2, then they should update their text to say 2. Have a go, pause the video, and I'll be back in a minute. Okay, hope you gave that a go. I'm back. Let's head over to the code and let's make that variable, or sorry, that method. So we'll fix the error in a minute. We'll make a new method and we'll call it private void client handle queued units updated. Now remember, these take in 2 variables of the type of whatever you're syncing, which is an int. So old units, int new units. And to update the UI, we just say queued units text, or remaining units text, text equals, and it's just this value of new units, but as a string, because it's an int, so let's change it to a string. And if we copy paste this method name, we'll go up to the top, and for whenever queued units updates, we want this to be the hook. So hook equals name of this method. We need to store one other thing, which is reference to our player, so our RTS player, and that's so that we can check how much money they have or if they have enough resources to produce the unit. We're now going to need an update method, but we can't make it in the server or the client region because part of it is for clients and part is for servers. So we need to just do it like this by making a private void update. And in here, we just say if is server, then do this. And if is client, do this. And if they're a host, they'll do both. So every frame, the server should handle producing units. So produce units, we'll make a method for that. And client should handle updating their UI to make sure the timer fill is accurate. So update timer display. We'll scroll down, and here we'll make a new method for the server only, and this will be private void produce units. So how producing a unit will work is we're first of all going to check, well, if there are no queued units, then just return. But if there are queued units, then we've got to use the timer. So let's take the timer, unit timer, and we'll add on time.delta time. So we'll keep increasing the timer. And if that unit timer is less than however long it takes to spawn a unit, so the unit spawn duration, if it's less than that, then we return. But if we get to this line here, it means that there are some units queued and we've reached the timer, meaning we want to now spawn in the new unit. To spawn in the unit, we can take some code from down here. Let's cut and paste it up here. We already have spawning, but we can't spawn in this because it's now a unit, not a prefab. So we can say .gameObject to actually get the game object from the unit. So we spawn in the unit, we spawn it in over the network, and now we want to move it nearby so that it's actually not going to stack on top of all the other tanks that get produced. So let's just calculate some offsets. So we'll say vector free spawn offset equals, and we already have the spawn move range, but we need it as a vector free, a place in 3D space. So what we can do is we can use random dot inside unit sphere multiplied by. So this will just give us a random vector free with a size of 1. It returns a random point inside a sphere with a radius of 1, multiplied by our range. So instead of 1, it's a radius of whatever our range is. But we also don't want it to go up or down. We want it to stay at the same height as where we are right now. So we'll say here spawn offset dot y is equal to our wherever we say to spawn in at. So unit spawn point dot position dot y. So we make sure those are the same now. And then we tell the movement script on the unit to go to that place. So unit movement equals, and then this unit was spawned in, dot get component, unit movement. And then tell it to move, so unit movement dot server move. Oh, sorry, we don't have that method, so let's go over there. Currently we have a method to move, which is this command move, and that's for clients to call. We don't have anything for the server to call. So let's make a server method called server move. And server move should just do this, so we'll move it into here. And then command move should just call server move, though it does need to take in a position. So what we can do is we can just pass in position. Whoops, pass in position. And then make sure this takes in a vector free position. So how this works is the command move is like the endpoint at which the client can call. So as a client, I say command move, and then it says on the server, it runs this code. But this, if we make this public, it allows us to then jump back over and say server move. So now we can call it on the clients and on the server. Because keep in mind, commands, if you tag something as a command, it's call it from a client to run on the server. So it's not, as it says here, not possible to call this from a server. That's why we need this, so we can call it in both places. And remember, this offset is just an offset, so we need to add that to where we actually are. So unit spawn point dot position plus the spawn offset. So our tank will spawn, and then it will move somewhere nearby, and then we want to reduce the queued units, so queued units minus minus, and reset the timer back to 0. Unit timer equals 0. But then if we go down here, the command spawn unit is pretty empty. So the first thing we want to say is, well, if queued units is equal to the max unit queue, so if that's the case, then return. It means you can't spawn any more units in. Then we want to check if this player has enough money or not. So we'll just say int resources equals the connection to this client, dot identity, dot get component, RTS player, and we have the method to get resources. And if resources is less than however much the unit costs, so unit dot resource cost, if it's less than that, then it means they don't have enough resources, so return. But if they do, let's increase the queued unit, so queued units plus plus, and then take money off the player. So actually we should get reference to the player rather than their resources here, so let's say RTS player equals and then don't call get resources, so we get the player here. Then we say player.get resources. So it looks like this now. Then down here it allows us to say player.set resources to be however much they're on, so player.get resources minus the price of the unit. So unit prefab dot resource cost. So this is fine now. The client code will still just call that like usual. There's one last thing we need to do, which is to actually update the timer display, the little image, the fill image. We don't do that currently. If we look up here, we made a method update timer display, but we don't actually have it anywhere. So let's copy the name and we'll go down to the client code and we'll make this over here and we'll say private void update timer display. Now that image fill goes between 0 and 1. So what we need to do is we'll figure out how much should we fill. So floats new progress is equal to the unit timer over however long it takes to spawn. So the unit spawn duration. That'll tell us how much we should fill up the image. And keep in mind, when it fills up to full, it then goes back to 0. So we need to take that into account. We'll say if the new progress is actually less than the unit progress image.fill amount. So that means if we've looped all the way around and a unit has just been made, then we want to just set it. So unit progress image.fill amount equals the new progress. Otherwise, we actually want to smoothly interpolate the values. So because keep in mind, the server's only going to tell us every few frames what the new value is, and we don't want it to be jittery. We want it to smoothly go between. So we can use a built-in math function to do this for us. We can say unit progress image.fill amount equals, and we can use something called mathf.smoothDamp, and that's built into Unity. We pass in our current fill amount, so let's do it on a new line. The current is unit progress.fill amount. Next is target, which is just the new progress. That's what we want to go to. Then we also need to give it some reference float for the velocity, and that's just a variable we store for Unity, and it will use it every time it calculates a new value to figure out the new value after it's done smoothing. So we can just say here ref and then make a variable name. We'll define it in a second, called the progress image velocity. And then finally, the actual value of smoothing. So this will change how fast or how slow it updates. So I usually find a value of 0.1 works pretty well. And let's end with a semicolon. And then we can take this progress image velocity and go up to the top. And we actually don't even need the player variable. So let's just change this to be a float called progress image velocity. And now Visual Studio Code is happy. So a quick rundown of what we've got here is every frame, if you're the server, you try and produce units, which says if you've got no units, then don't do anything. Otherwise, increase the timer. And when it's ready, spawn in a unit, move it somewhere nearby, and reset the timer. Then up here again, if you're on the client side, you keep getting this new value of the timer, and you say, well, if it's looped all the way back around, then snap it back to the top. Otherwise, if it's just increasing normally, then use the built-in math function to smoothly go between this value and this value. So make sure everything is saved, close these scripts, and head back into Unity. And we just want to make sure that if we go to our unit spawner and scroll down, we need reference to the unit prefab. So let's go to our assets, prefabs, and drag in our unit prefab. The text is the remaining units text. The image is this timer image. And then these values will do for now. I'm going to give it a build and see if it all works. Let's see if it works. So we'll add in our spawners. And we didn't add the face camera script, did we? So these should be facing the camera like the health bar, and we can add that in a second quite easily. If I now click on here, because it's not facing the camera, you see the numbers back to front, but that's fine. And it produces a tank, and then the tank moves somewhere nearby. It then keeps producing the next one, then moves somewhere nearby. And I can come over here and start doing it. Now, yeah, again, the UI looks a bit weird because it's like this. And we can actually I can show you what it would look like, because we can head back over here, go to our unit spawners, and we could just stick on to the unit spawning canvas the face camera component, so it looks like this. Just keep in mind that when I exit the game, I'm going to have to actually add it back, because changes in play mode don't actually save. So just before we end off the video, let's stop playing, we'll stop this, and we will go back to the unit spawner, back to the canvas, and stick on the face camera component. And if we just hit play now, I'm not going to bother building again, but we'll see if we maximize host, drag in a spawner, it looks fine. So it starts, I clicked it 3 times, so it goes up to 3, it goes up, 2, and then it fills up again until the next one's ready. So it's producing that unit. 1, produces the next unit, and then we are done. So yeah, that's it for this lecture. I hope you enjoyed. We're now ready to move on to the final few lectures where we can work on making the game a bit more fun by making the map bigger, adding a mini-map and camera controls, as well as adding more types of units and buildings. So that's it for now, and I'll see you in the next one. Goodbye. Hello everyone, and welcome. In this lecture, we'll be adding building limits so that when I click on my building, it will make sure I have enough money, which I do. And as I get close to a building I already have, it will change to green to indicate, yes, you can place this building here. It stops me from overlapping with my other buildings. And then if I was to place it here where I'm allowed to, it'll place it. And then because this building exists, it now allows me to place buildings over here because that's in range. So I can actually branch out my buildings like so. So yeah, that's what we'll be doing in this lecture. Let's get started. So let's add those limitations to our buildings, because right now we can place them anywhere. Doesn't matter if we have enough resources or not, and it doesn't matter if they overlap with other buildings. Of course, we want to deal with that. So let's head over to our scripts, buildings, into the building button. So the building button script is completely client-side. So anything we do in here is just visual, and it's to tell the server where we want to place the building. Then over in the RTS player script, this is where the logic is actually ran in this command. And this is where it's validating, are you allowed to place this building at this position? I think we should do the server-side logic first because that's all the behind-the-scenes stuff. And then on top, we can just add the UI, or not the UI, sorry, but the visuals to display whether we can or can't place the building. So we currently check, is this building an actual building? It is. Okay, we go down here, and then currently we just spawn it in. So rather than just spawning it in, let's make sure they have enough resources. So if resources is less than the building we want to place dot, and then it has a price or a resource cost, so get price. If we've got not enough resources, then we want to return. Okay, at this point, they've got enough resources and the building exists, but we aren't checking, is it in range or is it overlapping something else? So what we should do is we should grab the collider for that building. So what we can do here is we can say box collider, because all of our buildings are using box colliders. We'll call this the building collider. And we can just grab it from the building. So building to place dot get component, dot get component box collider. And with this, we can check if we're overlapping something. So we can say if, and there's this thing called physics.checkbox. And with that, we can pass in where do we want to check. So we're going to need the point where they are trying to place the building, plus, and then the center of this collider. So the building collider.center. So that's where to start this checkbox. And then it wants to know the half extents, which is basically just half of the size. It's how far it is from the middle to the edges. So all we need to do here is just take the building collider.size and halve it, so divided by 2. We can start putting this onto a new line because it's getting a bit big. And on the next line, we then want to give it the rotation, which we can just leave as the default rotation. So quaternion.identity, if you've used Unity before, this will be familiar. And finally, we want to give it a layer mask, which is going to say, which things should we be checking for. Now, we don't have this yet, so let's call it the building block layer. And for this, we've used layer masks before. We can add one at the top here. We can say, serialize field, private layer mask. We'll call it the building block layer equals a new layer mask. It's a new layer mask because it's a struct. And what we want to do here is we want to say, for example, we want to check if we're overlapping other buildings, terrain, units, whatever you want. So now what are we missing? We're missing a semicolon. Except this is an if statement, so it's not a semicolon. We're going to open up some curly braces like this. And what do we want to do if we do collide with something? We want to return, because it means we're overlapping, we're not actually allowed to place it there. Next, we want to check if we're in range. So over here we can say like bool in range equals false. And then we want to say, let's go over all of our buildings and see if we're in range of any of them. Because the way I'm going to do this is, to place a building, it has to be within a certain range of our other buildings. Any of them will do. So you can place one building, then place another one near that, then place another one near that. That's how I'm going to do it. So we'll say, let's loop over all of our buildings. So for each building, building in buildings, or my buildings, we're going to need an actual range limit, like a setting for that. So we'll go up to the top and we'll add a serialized field, private float, call it the building range limit. And we'll set that equal to a default value of, let's say, 5. And we'll head back down. Yep, head back down. And then to do this check, we can say, well, if, open up 2 brackets, and we'll say if the point, so where we want to spawn in the building, minus wherever the building is, so the building that we're checking's position. And then we can check the square magnitude. So that's better than doing square roots, because doing square roots is very expensive. So we'll check if the square magnitude is less than or equal to the building range limit. But since we're not square rooting it, we have to instead square this. So building range limit. And this also is quite a long line, so let's split that up here. So if this building in the loop is in range, then we can say we are in range. So in range equals true, and we can break out of the loop. We don't need to check for any other buildings. We know we're in range now. Then we can say, well, if we're still not in range, then return. It means you're trying to place the building miles away. Otherwise, spawn it in. And finally, we want to set the money, or set the resources. I keep saying money. And what's the new value? Well, it's the resources minus the building to place dot get price. So now this method will be told where we want to spawn in the building and which building. We'll make sure the building exists. We then make sure we've got enough money. We make sure we're not overlapping anything. And then we make sure we're in range of another building. And if we are, then we will spawn it in and reduce our resources. Now the thing is, we want to actually reuse some of this code in the other script. So I think what we should do is actually make a method that does this logic, and we can put it into a public function that we can call in the other script. So we're going to go down here and make a public method, but this method can actually be called on the server and on the client. So I'll do it outside of the regions. So this is going to be a public bool can place building. And to take into this, we're going to need the collider for the building. So we'll take in a box collider, building collider. And we're also going to want to know where we're trying to place it. So we'll say vector free point. And if we go down here to where the code is, we want to cut this line starting here and going all the way down to here. And if we go all the way back up, paste it in, we'll need to do a few adjustments. So we'll be saying here, well, if this is overlapping, then we want to say false. We say we can't place the building. Then we're going to assume here that in range is false. And if we find a building in range here, then we kind of actually just want to return true. But if we get to the end, it means we didn't find a building, so we want to return false. And that means we don't actually need the in range bool, so it will look something like this. We now want to go down here and call it. So all we want to do here is just say if not can place building, return. And that will require us to pass in a collider, so the building collider, and a point, which is the point from up there. And we're good to go. So now all the server-side stuff is done. We can go back over to the building button and scroll down to where we do some checks. So first of all, we're going to want to check when we put our mouse down, on pointer down, we want to check whether we have enough money. So we'll just say here, if the player.getResources is less than the building.getPrice, then don't try starting all this. And if we scroll down here to where we have our current logic for the preview, we want to update the renderer color based on whether we can or can't actually place the building. So what we want to do is use that function we just made to change this color. And now if we go down to where we update the preview, we want to set the color here. So we already have the renderer, so we can say the building renderer instance, we already have that. And it has a .material, and you can call set color. It needs a string for the name, and as you see here, its example is underscore color, which is, well, what we want here is to set the underscore base color. That's what Unity uses for this, at least in the universal render pipeline. And then the second parameter is the actual color value itself. So we should say here, color equals, and it's going to be basically green or red based on whether we can place the building. So we can say here, color equals player dot can place building, and then we'll pass in some stuff here, and that's going to return a bool. So we can say question mark. So that means that if we can place the building, use color dot green, and if we can't, so use a colon, then we use color dot red. So it's going to go green or red based on whether this is true or false. And then we can just pass that color in here. So we need to give this the building collider and the point. So we'll just make up the name for the building collider. And then we'll pass in the point as hit.point, which we get from this raycast here. Let's go make the building collider. So we'll make a private box collider, the building collider. And in start, we'll just say down here, the building collider is equal to, and then we can just grab it from the building itself. So we can just say building dot get component box collider. And the reason we grab the box collider anyway is just so we can easily grab the width, the height, the size, the position of the collider, so that we can do the simulation to check whether it's able to be placed in that place. And that should be it for the code, so let's head back into Unity. So now if we head over to our prefabs and look at our player prefab, you'll see we have the RTS player with this building block layer, and it has nothing set on the layer mask. So now it's time for your challenge, which is to set up the building block layer. So go to the layer mask, which I've already done with you, and it's simple, just add all of the layers that you want to make sure the building doesn't overlap with. So it's stuff like other units, other buildings, the terrain, that kind of stuff. So just have a go, pause the video, and add the stuff you think should be in there. Okay, I hope you gave that a go. Welcome back. Let's head over, and the layers we want to put in here, like I said, so we're going to want to use the default layer, which is the buildings. We're going to want to use the terrain, which will be anything we add like walls and, various objects in the terrain. Units, that's kind of up to you. I don't think we should be able to place buildings wherever units are. It might have some weird behavior, so let's not do that. So stop us from colliding with units. And, projectiles, I don't think that's any problem. The minimap stuff doesn't matter. Floor, the reason why I don't think we should put floor is because, the building collider, if the floor is slightly uneven, might just stop you placing buildings altogether. So we don't really need this. We know that it's going to be placed on the floor anyway, so because that's where the raycast will hit. We should be fine with this, so just these 3 layers will do. I think we can now give it a build and play. So here we are in the game, and I should be able to click and drag on my building, and we now see it on the terrain, and it's red. Now technically the material's red anyway, so we'll be sorting that out when we add team colors, but this is red, and you'll notice how when I get into range of my other building, it goes green. And it goes red if I stay out. So you can actually see there is a range here. If I go around, it's green, but as soon as I go too far away, it goes red. So it indicates to me that I can place the building here. And I can't overlap it. It'll say, nope, you can't overlap, it goes red. But as soon as you leave and it stops overlapping, it goes green. So I can place a building here. And then now, it actually extends the range, so I can now place a building here, and over here, and over here, and over here, and so on and so forth. It also works for other types of buildings, so if I take this spawner, I can place it down here and start spawning in units. So yeah, that's it for this lecture. We now have building limits in place, and they are server authoritative. And now we can work on adding minimap and camera controls to make the game a little bit more fun. We'll make the map a lot bigger and the units a bit smaller, so that everything feels like a proper RTS game. So I'll see you in the next one. Goodbye. Hello everyone, and welcome. In this lecture, we're going to be adding team colors. So if you look here, when I spawn in buildings for this player, red building spawn, and over here it's green. And the buildings themselves, or the colors, are chosen randomly. If we were to bring this tank over here and compare it to this tank, you will notice they are different colors, but it will be quite hard to actually tell, and that's because the tank model is green by default, meaning when we make it red, it's a mix of green and red. So if you look carefully, they are different colors. Based on your model, you'll be able to tell maybe easier than this, but for now, it works. We do assign colors, and we can come back later and make some adjustments to the model to make it a bit easier to see. So yeah, that's what we're doing in today's lecture. Let's get started. So we need somewhere to store the player's color, so let's go over to the scripts, and I think the place that makes the most sense is the networking RTS player. And just like how the server will store the list of units and buildings for that particular player, it should also store their color. So let's store a private color, and we'll just call this the team color. And by default, we'll just set that equal to a new color, but the server should set it, so it'll be fine. We will need a getter so we can grab it elsewhere. So let's make a public color get team color that returns the team color. We also need the server to be able to set the color. So if we go down here, we've got set resources. Let's make a new one. Server public void set team color, taking in a color. We'll call it team color. And all this should do is just say, oh wait, let's say here, new team color. Team color equals the new team color. And this method, or these methods, both of them are server methods. So let's cut them because currently they are outside of the server region. So we'll do them just before or just after the start and stop. Now the player's done, we can head over to the network manager, and this is where we need to actually give them a color. So we can say here, we want to grab the player object. So this is con.identity.getComponent.RTSPlayer. So the player for this connection, and let's store it as RTS player equals. And then we want to give them a random color. And we actually did this all the way back in section 1. So at that time, I think I made it a challenge, but we're not going to do a challenge again. We'll just do it the same way we did last time. So we'll make a set team color, and it takes in a color. So let's make a new color, and we want to pass in RGB. So we'll just use unityengine.random to give us some random color. So unityengine.random.range between 0 and 1. And then we can copy paste that and go comma, paste, end with a semicolon down here. So now whenever a player joins, we set their team color. But currently all that does is just stores it in the player script. We don't actually do anything with this right now. We just have it here. So we need to make a new script that we can stick on units and stick on buildings. And whenever they spawn in, it will ask the server, or the server will tell it, you're this color, so set your renderer. So let's head back into Unity, and we could do the script wherever. I think we'll just do it in this networking folder for now. So we'll just call this the team color setter, and we'll open that up. So the team color setter is a network behavior because the server needs to do some stuff and tell the clients to do some stuff. So we do need it to be network. So network behavior, import mirror. Get rid of the start and update methods, and we're ready to go. So we need a reference at the top to some renderers because at the end of the day, what we're doing in here is changing the color of this object. So if we make a renderer array, it means that our object, let's say it's made up of 5 different renderers, we can say, you know, these 3 should go red and these 2 should stay the same. So we'll get to that when we drag them in the inspector. But this can be called the color renderers, like this. We'll set that equal to a new renderer array of size 0. We then want some server code, so I'm going to make a region for the server and a region for the client. So the server needs to grab the color from the player and tell all the clients, you know, to change their color to be this. And if we add, let's say, spectating and clients join later, we want to make sure they also get the color. So we can't use an RPC because RPCs happen when they're called, and late joining clients don't know. So we need to use a sync var for this. So let's sync var the color. We'll say here sync var a private color called the team color, and we'll just set equal to a new color by default. And in the server code, we can say override on start server. So when this object starts existing on the server, we need to grab the player for this thing, for this unit, for this building. We'll grab the player and we'll find out what their color is. So RTS player equals the connection to this client dot identity dot get component RTS player. So we now know who they are, and we can simply set the team color in here to be that players get team color. So now all the players are aware that this particular object should be, let's say, red or green or blue or purple. But they also need to have some code to say, actually change the renderer to be that color. So we should use a sync var hook. So let's make a method on the client side to actually do the rendering. So private void handle team color updated. And this needs to take in the old and the new color. So color, old color, color, new color. And whenever we get this new color, we just want to go over all of these renderers and change their color. So it's just renderer, so for each renderer in the renderers, then we want to set their color. So renderer.material.setColor, and if you remember from last time, it's underscore base color, and then the second parameter is the actual color itself, which is new color. And finally, we take this method and we need to tell mirror to call it whenever this variable is synced. So we say here hook equals name of this method. Okay, so a quick recap of what's happened. A player joins and we set their team color, and the player script stores it. Simply just stores the color. Then whenever something, because we'll be putting this on buildings and units, whenever something like a building or a unit spawns in, the server will say find out which player owns this object and store their color in here. And that will then sync to all the clients, whether they're there at the time or if they're late joining. And then whenever they do get that value synced, we will go over all their renderers and set their color. So if we go into Unity, and now we can just pick something that changes color whenever we spawn in. So if we go to our prefabs and we go to, let's say, the unit, this unit has a few renderers. If we were to look at the tank, it's got over here it's got one renderer with two materials. So what we want to do is on the unit, make sure it's on the base, we can add the color setter, team color setter, and then on here we just drag in all of the different renderers. So in our case, we're just going to drag in the tank with laser cannon. And now it's time for your challenge, which is to set up the team color renderers for everything else. So go to each object that you want to change color to match the player's team color, add the team color setter component, and then drag in all of the renderers on the object that you want to change the color to, just like we did a second ago. So have a go, pause the video, and go set up all the different things. Okay, welcome back. I hope you paused and gave that a go. What we can do is we can go over to, now sadly we can't just go to the building base prefab because this has no renderer on it anyway. I mean, we can technically add the team color setter here, but then we'd have to actually go through each building and set it anyway. So let's go to the resource generator. And if we look down here, we want to drag in the resource generator preview, or sorry, open up that. It's actually the cube. So we'll drag in the cube, go down here, add the cube. We can then go to the unit base and do the same thing. So we'll just drag in the cube to the renderers, go to the unit spawner, and drag in the preview cube to the renderers. So we've done the resource generator, unit base, and the unit spawner, as well as I did the unit with you earlier. So that should be everything. Technically, if you want, we could also go across to the projectile. Since the projectile belongs to a player, we can add the team color setter, drag in the projectile itself. So now the projectile color will match your team color. Okay, I think we can give this a go. Let's build and see if it all works. Okay, so I'm hosting in the editor. We've got a blue player and we've got a green player. So if I spawn in some buildings, they're also green. Whoops, they're also green. I'll spawn in a unit and I'll do the same over here. Blue buildings, spawn in a unit. And the units will be quite hard to actually determine the color just because of how the materials are set up. So it might not seem like these players right now are different colors. I mean, if you look at them very closely, they definitely are. So we could do some more work on making them easier to distinguish, but they are different colors. It does depend on what model you're using, because you could make the highlight be the color instead, and that would be a lot easier to see, because these tanks are already green in the model by default. So when you set it to be blue, it's actually kind of a mix of green and blue. So it is harder to see. It really just depends on your model, but it works. So yeah, that's it for this lecture. We now have team colors, so it's a lot easier to tell which players are which tanks and which buildings. All we've got left really is camera controls, minimap, and a lobby. So I hope you're looking forward to that, and I'll see you there. Goodbye. Hello everyone, and welcome. In this lecture, we'll be adding camera controls. So now we can hit WASD, sorry. We can hit the arrow keys, it does the same job. And we can put our mouse at the corner of the screen to move around. We can still, of course, do what you'd normally expect with moving the camera around, hit your units, go over here, do some management with your units, come back, grab these units when they're ready, send them over here. You can do all that fun stuff, and it all works with the new camera controls. So yeah, let's get started. So I think it's time to add some camera controls now. So the first thing we want to do is set up the input for it, and we're using the new Unity input system. So the way we should do this is go to our project, create a new folder, and we'll call it inputs. And this is where I want to put my input actions asset. So if you go to create and we try and find it on here, it's near the bottom, input actions, we'll create one of those and I'll call it controls. Then what we'll do is we'll tick this generate C# class and we'll put in here assets/scripts and we'll make a folder for it called inputs. And then the file name is going to be controls.cs. The class name can be controls, and we'll just leave the namespace as blank and hit apply. You'll see now that if we go over to our scripts folder, inputs, it's actually given us an inputs folder and this C# script that we don't have to actually look at because it's going to make it for us. So now we can double click on the controls asset and we get this window here. And we're not going to spend too long on talking about all the different configurations, but what we do want to do is make it work for keyboard and mouse. So I'll say over here, add a control scheme, and I'll call it keyboard and mouse. And to this list, I'll add keyboard and I'll add mouse. And then what it will do is it will detect which of these I've got plugged in. So what I could do is I could say, if I save, I could then add a new control scheme and then say, Xbox controller. And then what it would do is it would swap to use that scheme if I had an Xbox controller plugged in. But for now, we're just using keyboard and mouse. So I'll say here, we need a new map, and I'll just call this player, and then all the different player actions. And for now, it's just going to be the camera movement. So we'll call this action move camera. And moving the camera isn't a button, it's actually a value, because it's an X and a Y. We need to know to move the camera forwards, back, and left and right. So we'll say value, and it's an X and a Y. So on here, change button to vector 2. Then if we open this up, you see it has no bindings. And what we want to do is say we have one binding, which is WASD, and another one might be the arrow keys. So let's delete this binding, and we'll right click and add a new 2D vector composite, and we can call this WASD. And we can add another 2D vector composite and call it arrow keys. And now you just want to go through here, click on the first one, up for WASD is W, down for WASD is S, left is A, and right is D. Then for arrow keys, type in up, arrow keyboard, down, arrow keyboard, left, arrow keyboard, and right, arrow keyboard. And now these are set up. Once you hit save, it'll actually recompile that script that we had, that it's made for us, and now we can use this in our other scripts to drive the camera controls. So now we need to actually put the camera in the scene. So if we go to our player, what we're going to do is we're going to have a main camera in the scene, and then we're going to have some Cinemachine cameras which don't actually do the rendering, they just control the main camera. And what we can do is we can give one to every player. So if we add an empty game object and call it the camera, and add on the Cinemachine virtual camera. This isn't an actual camera that renders, like I said. What it'll do is, when it's active in the scene, it will override and control the main camera. So it means we don't need to have tons of cameras in the scene, we just need one, and this will actually control it. The problem is, if we put this as a child of the player object and we have 4 players, then there'll be 4 of these active. So we need to disable this game object by default and then turn it on whenever we actually want to, whenever our player spawns. So we don't turn it on for others, only for our own player. And we do want to initialize the rotation and the height. Now, you can add zooming in and out later on if you want, but for now we'll just keep it at a constant height. So we'll say 10. And then we'll also say over here, with a rotation on the X of 45, so the camera is angled down. The reason it looks a bit weird is because there's no actual camera in this prefab view. So if we were to go back and go into our scene where we have the gameplay, so scene map 01, on the main camera, we have to add a component called the Cinemachine brain. And this is what actually allows the player script to override this value. So just by having that on here, it will allow our player camera, so if we go back to prefabs, player, this player camera will actually control it now, and you can even see it up here. And we want to write a script to control it, but we shouldn't put it on the camera itself because this isn't a networked object, but the player is. So we'll be putting it on here. Let's go back to our scripts, and we'll add we've already got a cameras folder, so we'll make a camera controller, and we'll open that up in Visual Studio Code. So this is a networked object. We're used to doing this now using mirror. And what we'd like to do is we want to have reference to the camera itself, because like I said, this is on the root player. So we'll add a private reference to the transform, the player camera transform. We then need some settings. So we need a speed. So speed equals, let's say 20. We need a kind of border thickness, because as well as controlling with WASD and arrow keys, we also want our mouse to control it. So if we put our mouse cursor to the corners of the screen, it should move the camera. So we'll say the float screen border thickness. So this is like how close you have to be to the edge for it to actually start moving. So we'll say 10. And then we also need some limits for the camera movement, because there is, a maximum X and Y, or an X and Z value that you can go to. So we need to say here, a private vector 2. This is going to be the X limit, so screen X limits. So the min and max is the X and Y of this vector, equals vector 2.0 by default. And then also here, we'll say the vector 2 screen Z limits. So like I said, on start authority, we want to turn it all on because we'll make it off by default. So on start authority. So this will be only for ourselves, for our own camera. We want to turn it on. So player camera transform.gameObject.setActive true. So we're going to set our camera active. And then to use the new input system, we need to actually make a private, and we called our thing controls. That's our own class that it made us. It looks all weird. That's because it's auto-generated. But private controls. Then we say down here, when we start authority, controls equals a new controls. And if you remember earlier, we made the player map with the move camera command. So controls.player.move camera. And how the input system works is we don't actually read the input every single frame. We're told by an event whenever it changes. So if I just hit the W key and don't let go, it just does it once. It tells me that I basically pressed W, and that's it. And then if I release the W key, it then is known as cancelling the event because there is currently no input. So I need to listen to when I perform the action and when I cancel it. So .performed, and then controls.player.moveCamera.cancelled. So these are two separate events we need to listen for. And whenever our input changes, we need to store that as a vector2 because that's what we told the input system it would be a vector2. So private vector2, and then we'll just call this the previous input. And we need a function to actually set this whenever this happens. And if you look here, the data it returns is an input action.callback context. So what we can do is we can make a method, private void set previous input, and then this will take in an input actions, so input actions.callback context. And we can call the variable ctx for context, and this is actually input action, not input actions. And if you hit control period now, it lets you import unityengine.inputSystem. And now all we do is we say when it's performed, set previous input. When it's cancelled, set previous input. And with the input system, you don't need to unsubscribe from the events. As far as I'm aware, I've not seen them do that in any of the documentation. It's handled for you, so we can ignore unsubscribing in this case. And what actually happens when we're told that our input changes? Well, we want to set this previous input to be equal to, and from this context, you can call a function called readValue, and it doesn't actually know what type of data is coming in. We know, though, as the developers, so we can tell it inside the angle brackets that it's a vector2. And finally, once you've set everything up with the controls, you have to call .enable. And there we go. So now we fully handle taking the input and turning on the object. All we need to do now is actually use that input to move the camera. I'm not going to bother with a region because this entire script is client-side. And if we make an update method, let's say here, private void update, this is only for clients, so I'll make a client callback. And now this means only the clients will run it. And to be honest, because this is off, oh sorry, no, this isn't off by default. The camera's off by default, but the script isn't. So what we need to do here is say, well, if we don't have authority, if not has authority, then return. So we don't try moving other people's cameras. And we also want to say here that if we're not focused on the application, then also return, because otherwise if you tab out, then your camera will start panning across the scene. So we'll say if we don't have authority or not application.isFocused. And that's just a thing in Unity that tells you whether you're focused on the game. If we do have authority and we are focused, we'll make a method called update camera position. We'll do that here, private void update camera position. So we need to say what is our current position. So vector free pos equals the player camera transform dot position. Then we'll say based on whether we had keyboard input or not, we want to move or not. So say if the axis input, so if the previous input is equal to vector2.0. So if we didn't put anything in on the keyboard, we want to check if the mouse is in one of the edges of the screen. And if we're in the top right, we also do want to go diagonally. So we'll say here, vector free cursor movement equals vector3.0. We then want to read the mouse position, which is a vector2. So vector2 cursor position equals mouse.current.position.readValue. And now we can check where the mouse is on the screen. So we'll say if the cursor position.y is greater than or equal to the screen's height, so screen.height, minus the screen border thickness. Remember, we made that so that you don't have to be on the topmost pixel. You can be anywhere within the thickness, so maybe let's say 10 pixels from the top of the screen. If that's the case, then it's cursor movement.z plus equals 1, so that we want to move up a bit. And then we want to say, well, else if cursor position dot y is actually less than or equal to this, the screen border thickness, because obviously the bottom of the screen is 0, so we don't have to say 0 plus, we'll just say the thickness. Then we want to say cursor movement dot z minus equals 1. And then we want to copy paste this, so it's another if and an else if. And this is now cursor position dot x, if that's greater than the screen dot width minus the thickness, then this is x plus equals 1. If cursor position dot x is less than the thickness, then it's x minus equals 1. And now all we want to do is modify the position of the camera based on this. So we'll say here, pos plus equals this cursor movement. But the problem is, if our cursor's in the corner of the screen, it'll actually move faster. So we need to normalize the value, and that just makes sure that regardless if we're going up, down, left, right, diagonal, it will all be the same magnitude. And then we'll say here, multiplied by our speed, multiplied by time.delta time, so it's frame rate independent. And remember, this if here is checking if we had keyboard input, or if we didn't. If we do have keyboard input, then we do this else. So we say pos plus equals, and we need it to be a vector free, so a new vector free, where the x is our previous input dot x. The y is 0 because the height doesn't change, and then the z is previous input dot y. And this is also then times by speed times by delta time. Time dot delta time. And finally, we want to make sure that we're not out of bounds. So we can say pos.x equals, and then we can clamp the value. So we're clamping the value pos.x between the screen x limits .x and the screen x limits .y. And the same for the z-axis. So pos.z equals mathf.clamp, pos.z, and then the minimum is screen z limits .x, screen z limits .y. Now keep in mind, this x and y, we're not actually meaning the x and y coordinates. It's just because we're storing this data as a vector too. So the first value is the x and the second value is the y. So think of these x and y's as the min and max of that value. And finally, let's actually move the camera. So player camera transform dot position equals this new pos. And that's it for the camera movement. So we now say every frame, if we had no keyboard input, then get where the mouse is, and if the mouse is in the edges of the screen, then try and move it in the various different ways. And if we did have keyboard input, then just add that. And then finally, make sure we stay in the limits of the gameplay space, and then update the position. Let's head back into Unity. And now it's time for your challenge, which is to set up the camera. So add the camera as a child of the player prefab. We've already done that. Disable the camera game object. Don't think we've actually done that yet. Add the camera controller component to the player prefab, so the script we just made. And then set the reference to the camera transform and tweak the settings until it feels right. Have a go, pause the video, and I'll be back in a minute. Welcome back. I hope you paused and gave that a go. We'll head over to our player. We'll add on the camera controller component. I'm going to tweak the speed to be, let's say, 25. Add the camera reference here, this camera transform. We'll actually make sure to disable that game object. And then down here for the limits, I'm just going to put in the limits I'll be using when we change the map to be bigger. So I'll say minus 45 and 45. So that's the left and right. And then the forwards and backwards will be minus 55 and 35. And these values are different than these values, like, 45, 45. These are different because of the angle of the camera. And if we were to hit like pivot, obviously you see the camera is angled down. So based on wherever that angle is, you will have to change those values until it feels right. But we should be able to head back and build and see if it works. So I've hit play, we're going to host, and obviously I haven't tweaked the screen X and Z limits don't match what we actually do want for our little scene. But if I do use WASD or put my mouse at the corner of the screen, you see the camera does move around, and now our base is at the top right, but that's just because the camera spun around. It's not too important. But yeah, we can move around. We can still do everything we could do before. We can spawn in our buildings, produce units, but now it allows us to also move around the map. We'll also, in the next lecture, be adding a minimap so that we can easily get around to the other side just by clicking and going over there. And we can also see the different buildings and units and where they are. So yeah, that's it for this lecture. We've now made the camera controls and it all works. So I hope you enjoyed this lecture. We can now move on to make the minimap. So I'll see you in the next one. Goodbye. Hello everyone and welcome. In this lecture, we'll be making a minimap so that when we spawn our buildings, spawn our units, both players can see on the minimap where these things are. So if I go over here and then I start doing the same thing, I can spawn in some units. We see all the buildings on the minimap. I can now control my things and move them around. So we get these little squares for the buildings and circles or spheres for the for the units. So yeah, we have now this useful minimap. It'll look a bit more sensible once the map's bigger and the units are smaller, but that's all just balancing and fine-tuning at the end. And then in the next lecture, we'll be making it so I can click on the minimap to have my camera move around the map. So yeah, let's get started. So to make a minimap for our game, let's head over to the scene where we need it. So we'll go to Scenes, Map 01, and we're going to want a minimap to appear on the user interface at the top right corner. So in the hierarchy, we'll right click and make an empty game object. We'll rename it the minimap display. And then I'll reset the transform, so it's at 0, 0, 0, and I'll move it with the rest of the UI. I'll also drag it and put it in the prefabs folder with all the other UI, so that if you ever make other maps, you can just drag the prefabs in and they're all ready to go. And the minimap is some UI, so we have to right click on this game object and add a UI canvas. And we'll call this canvas the minimap canvas. I think that's the same naming we've done with the rest, or we've just called the others canvas, so yeah, let's leave it like that. And then on here, what we can do is we can go down to the canvas scaler and make it scale with screen size. I'm using 1920 by 1080, so do that. And then match height. This is the same we've done for all the other canvases. And we do need a graphic raycaster because we want to write some code that lets us click on the minimap and will teleport our camera to be there. So I think we should give it a background. So we'll right click on the canvas, add a UI image, and then on the anchors, we want it to be at the top right. So we'll click on the anchors, hold down Shift Alt, or Alt Shift, doesn't matter. Hold both of those down and click on the top right, and it gives you this setup. And then we want to give it a padding from the edge of the screen. So I'll give it a padding of 50. So we'll say minus 50 on the X, minus 50 on the Y. And then as for the width and the height, I'll make it 250 by 250. And I think this is good to go. Let's make the color a bit darker. I've got this color copy paste over here. I've gone for a gray where the RGB is all 75. And now the actual minimap view itself. So we're going to have a top-down camera that looks at the scene orthographically from top down, and whatever that camera sees, it will render onto the minimap. And then we can selectively ignore certain things to render or not to render. So this image is the background, we'll call it background. And then the actual minimap itself, I'll right-click on here and add a UI, and we're going to be using a raw image. So if we add raw image, and we'll call this the actual minimap itself. I want to give it some padding around the side or some border here, but I don't want it to be like this. So we'll click on the anchors, we'll hold down the Alt key, and we'll click at the bottom right, and that will stretch it. But then we need to actually put in a padding value. So I'll say 10 around top right, bottom and left. And if we look on here, we have this texture field, and that's going to be what actually is rendered on this texture. It's going to be the output of the camera. So we need to set up a render texture. So we'll add a new camera to the scene. So right click camera, and then we've got this new camera, but we don't want it to, actually look like this. We want it to, first of all, be orthographic instead of perspective. And then we're going to want it to aim down at the map as opposed to wherever it is right now. So to do that, we'll put the X as 0. We'll give it some height. So let's say 50. Doesn't matter the height really, just as long as it's above the map. And then 0 on the Z. And then the rotation should be 90 on the X. So we're looking straight down. And keep in mind, we're looking at this currently as a 1920 by 1080, but we're actually going to be putting it into this minimap here, and it'll be a square. And this size here will determine how wide the camera view is, how much we see. So if we make it bigger, we are effectively zooming out. So we want this to be basically the same size as the map itself. So the floor is 20 by 20. So we want the camera size to be 10, and it'll perfectly fit like this, which should be half of the size of the map. The background type doesn't matter too much. We could just pick a solid color for this background. Don't worry about everything else going weird right now, because we're going to make this not be the main camera. And then we also want to go into rendering and say culling mask. So culling is basically what you're rendering. We don't want to render everything. We only want to render certain things. So we don't want to render everything. Let's hit nothing. And then what do we want to render? We want to render this floor. So there we go, we're rendering the floor. Want to render anything that's tagged with minimap, and that's what we'll use for units and buildings, and I'll be showing that in a minute. And then we want to also render terrain, which would just be any physical objects on the map that we add, like walls or something like that. And if we scroll down, you'll see there's an output. So output here, we can output to a render texture, and then we can also, from the render texture, put it on the minimap. So let's go Assets, Sprites, and we'll make a new render texture, wherever that is. Here we go, render texture. And we'll call this the render texture underscore minimap. And for the settings on here, we don't really have to mess with it. I mean, you can if you want to, but for what we're doing, we're just going to go to that new camera and drag it in to the render texture. Notice how now that it's a render texture, our other camera becomes the main camera. And then if we head up to the minimap, we can also drag the render texture in there. And now it's actually displaying whatever that camera sees in the minimap here. And you can see that in action. If we were to mess with the size, you'd see here, it actually changes what that camera sees. So we've got the main camera in the scene. Let's call this the minimap camera. We'll go put it at the top of that. And now we can start actually tagging things as minimap objects, and then we'll see them on the minimap. We need to make sure though, if we go to the main camera, on its render culling mask, we don't actually want to render everything on here. The things we don't want to render now is anything that's tagged with minimap. So now if I was to go to our assets and go to the prefabs and let's say the base, the unit base building, and this is currently a square, and it's not going to be a square when we actually, import the models we're going to be using. But what we should do is in here, this square, this cube, sorry, is what the main camera sees when we're looking around the scene. And then the minimap should see something else, because I just want there to be like dots on the minimap to display your units rather than the actual models themselves. So what we can do is we can add another game object, let's say a cube, and we'll make it, it's the same size. We don't need a collider, so we'll remove that. And we'll move it up by 0.5 units, so it's in the same position. And if we just mark this with minimap now, what it means is that this cube, the gray one, will only be seen by the minimap camera, and the red one will only be seen by the actual main camera. And then when we add a model for the base to be this cool building, we can just keep this cube and maybe rescale it to match the building model we use. And so that on the minimap, we just see this like red dot or whatever color our team is. We see that dot on the minimap. And then in the actual game, we see the nice detailed model. The only problem is this cube is gray and it's going to stay gray. So if we just call this like we'll just call it minimap. It's not actually the minimap, but we'll call it like the minimap icon. And then back on the base, we have the color setter. And we're currently only setting the color of the cube. So let's also set the color of the minimap icon by adding it to that list. So I just loaded into the scene, started as a host, and you see we actually got like kind of a pink team color here. So it looks, ready pink on here. And that's actually the base on the minimap. And then obviously this building, we didn't actually add it to. So when we spawn this in, we didn't see it on the minimap, but that's fine. And you do actually see shadows on the minimap, and you can turn that off if you want to. And I think we should turn off shadows on there. But yeah, that's a really easy thing to do. And now we can go through all of our units and our other buildings and tag those as minimap. So let's go ahead and do that. But considering I showed you how to do it for the first building, I want you to have a go for your challenge to do it yourself for the remaining buildings. So we've done it for the base, so you need to go do it for the spawner and for the resource generator, as well as our first unit, the unit we have. And then in the next couple of lectures, when we add new units and new buildings, we'll do this along the way at that time. So for now, go through each object. I put player objects because we've already done like the floor itself, and there's no terrain yet. So go through those objects that belong to players that you want to appear on the minimap. Create an object to represent them, like a cube I just did, or a sphere, a sphere. It's up to you, whatever shape you want to use. Put the object on the minimap layer, that's an important part. And then add the object's mesh renderer to the team color setter to make sure it shows up as your team color on the minimap. So have a go, pause the video, and try and set that up for the other buildings and unit. Okay, hope you paused the video and gave that a go. Let's head back into Unity. So just like we did on our first prefab unit base, we've got this minimap icon here on a different layer. If you don't want to see it in here, you can actually just click the eye to hide it, but it does need to stay active, otherwise it just won't show up in the scene at all. So let's go from unit base to unit spawner, which in our case has the same model, but it's fine because we will be changing that. And what we can do here is we can add a new cube, get rid of the box collider, and call this minimap icon like we did last time. and then we want to put it at 0.5 and on the minimap layer. We'll now go over to the resource generator and we'll do the same thing real quick. So add a cube, call it minimap icon, and we'll put it on the minimap layer, 0.5 height, remove the collider. And one thing I just forgot to do in the previous one, so I'll do it now for both, is we need to go to the color setter, the team color setter, and drag in this thing. We need to do it for the unit spawner, I forgot. So here we are, team color setter, drag in the minimap icon. And then finally, it's the unit itself. So if we go to the unit that we have, we can make a cube or a sphere for it. It's not too important. I say let's go with a sphere just to show you it works the same way. So we'll make a sphere, and we want to make it kind of roughly match the tank. It doesn't have to be perfect. It's just up to you. I'd say this is a pretty good go at it. So we remove the sphere collider. We make sure the sphere is on the minimap layer. And then on here, we can say minimap icon. Now, if we go to the unit, go down to the color setter, and drag in the minimap icon. I think we should be able to head back and give that a go. Let's hit play and see what happens. Okay, so we're in the view. I'll move the camera over here. That'll be fine once we've made the map bigger and we've sorted that out fully. But we have our base, we see it on the map, and we drag in this building, and as soon as we let go, that also appears on the map. And if I produce some units, we're hoping they also appear on the minimap. So it'll become 1. And like you see here, we've given it this really big sphere, which is about the same size as the tank. So on the map, it isn't, it looks weird because they're so big, but it is correct. We do have some really big tanks right now. And when we make the map bigger, it'll be more zoomed out than this, but it shows that it works. You can now actually see on the map a kind of icon or, a representation of our tank. That isn't actually a tank model itself. You don't usually have models on the minimap, just, simple spheres and cubes as icons. You could even use 2D sprites if you wanted to, but we don't have those. We're just going to use cubes and spheres, and I think it works pretty well. Let's quickly go back and fix the shadow issue. So if we go to the camera, which is scenes, mapper 1, minimap camera, and there'll be an option on here to not render shadows. Simple. And then if we, go back and hit play, it should all be fine. Okay, so I've built, just so we can see it from both points of view. We see we've got pink and purple team. So I'm going to spawn in some buildings here, and both teams see it. I can spawn in over here a unit spawner itself, click on it, and it'll start producing that unit. And as the unit is ready, both players see it on the minimap, and I can go over here to the other team and do the same thing, produce some units, and we'll both see them on the minimap. And then I can start shooting. We still need to make the tweaks to the tanks because they rotate very slowly. They're huge and bulky, and maybe that's what you want, but we do want to make it feel a little bit better. So yeah, we can move on now to add minimap controls in the next lecture, and then do the final polish with models for the buildings and more tanks, more units, make the gameplay a bit more fun. So that's it for now, and I'll see you in the next one. Goodbye. Hello everyone, and welcome. In this lecture, we'll be adding minimap controls as an upgrade to what we made in the previous lecture with just the minimap itself. I can now click anywhere on the map to teleport my camera around, and I can also click and drag to smoothly move it around to that location. I hope you're looking forward to it. Let's get started. So let's make the minimap script. We're going to need one of those so we can detect the clicks. So let's head over to our scripts folder, and we need to make a minimap script, and because it controls the camera, I'm going to put it in the cameras folder. So we'll call this the minimap, and we'll open that up in Visual Studio Code. So let's get rid of the start and update for now. And in here, we're going to need a method to move the camera, and that's going to read our mouse input. Now, we only want to do that when we actually click or kind of drag our cursor on the minimap. So we'll add that bit in second. For now, let's just make the function that actually moves the camera. So we'll make a private void, we'll call it move camera. And we want to read our mouse position. So what we can do here is we can say vector2 mouse pos equals, and we can say mouse, and we're going to need to import the Unity engine.input system. So mouse.current, and then position.read value. We've done this a few times. So that's our mouse position on the screen. But that's in screen space, it's the huge screen. We want to know where it is relative to the little minimap square. So to do that, we actually need to tell it where the minimap is. So let's here add reference to a serialized field private, and for UI it's not just a normal transform, it's a rect transform, as in like rectangular transform, and we can call this the minimap transform, or minimap rect. And we want to say get where this position is inside this rectangle, but as far as our code's concerned, well, there's no guarantee that it actually is inside there or not. So we need to do an if. We need to say if, and there is a class built into Unity called the rect transform utility class here, and it has some methods in it, and we're going to be using one of them to say we want to get, if we look here, dot, and there's quite a few. There's one called screen point to local point in rectangle. And that's exactly what we want here. We want to take our screen point, which is this mouse position, where our mouse is on the screen, and convert it into a local point in the rectangle. So if our rectangle is, let's say, 50 by 50, we want to convert wherever our mouse cursor is into a coordinate between 0 and 50 on the X and Y. And like I said, there's no guarantee that this actually is inside the rectangle. So here it returns true or false based on whether that's, inside or not inside the rectangle. So we can say like, if not, then return. But then we have to pass some stuff in, and this is going to be quite a long line, so we'll split it onto multiple lines here. So the first thing we want to do is pass in a rect, so the minimap rect. Then the screen point, which is our mouse position. The camera, but the camera doesn't actually matter here, so we can just say null. And then finally, the local point, and that's an out, which means it will give back to us a local point. So we can say out vector2 local point. So then after this line, so we say return if this is false. So if the mouse position is not inside this rectangle, so the minimap, then return. But if it is, then we get down to here. And now the problem is our minimap is a certain size, but we want this to work regardless of the minimap size. If it's 50 by 50 or 100 by 100, it should still work. So what we should do here is we need to figure out a kind of percentage. So if our map is, let's say, 50 units across and we're at 25 units across, or pixels, then we want it to return to a 0.5. We want to know the kind of percentage that we are through it. And that means that if we then double the scale of our minimap, it's not going to break this code. And since we'll be using this value to interpolate on the next line, we'll call it lerp, which is to do with linear interpolation. And we'll make a new vector2. And like I said, I want this value on the X and the Y both to be, irrespective of how big the image is. So that means we'll need to do some division based on the width and the height of the image. So what we can do here is we can say, we'll take the local point.x that it gives us back, and we'll minus the minimap rect dot, and then rect.x. This is obviously a transform, then you can get a rect from it, which is a rectangle I see here, calculated rectangle in the local space. But both these values here are in pixels, and the problem with that is, like I said, if you change the size, then the pixel size changes. So with that, we're then going to also have to divide it. So let's put this in brackets. And we want to divide that by the width. So minimap rect.width. So for the Y, we then want to do a comma here, and we'll say local point.y minus minimap rect.y. So it's the same we did for the X, just for the Y. And then instead, here we're going to divide by the minimap rect.height instead of the width. So what we'll do is we'll make sure to do our brackets correctly. So we'll put the bracket there, and then this should be fine if we put a semicolon. And I'll put both of them onto the same line with the same indentation so you can read it a bit better. And now we have this value x and y that doesn't matter, at all what the height or the width of the image is, because it takes that into account. And then we need to figure out where we're moving our camera to. So let's make a vector3 new camera pos, and that's going to be a new vector3, and then the values are going to be dependent on the actual size of the map. So in here, we should pass in at the top the size of the map. Now we're assuming for this that your map is a square. So we'll just say here, int, or even float, map scale. And in our case, we're going to scale it up to 50, let's say. I mean, for now, it's 20. So we'll say 20 for now. And then down here, what we do is we say mathf.lerp So that'll give us back a value between A and B based on t. So let's say t is 0.5, it'll give us the value halfway between the two. If we put in 0, it'll give us A, and 1, it'll give us B. So it's basically a percentage between these two values. So what we have here is we have the min value being minus, and then the scale of the map. So minus map scale, comma map scale, and then lerp.x. Like I said, this value here is going to be between 0 and 1, which is what we want here. So if we click on the far left of the minimap, then it'll put our new camera position to be on the left of the map, just like we want. Now I'll put this onto a new line, and we also want the, let's do a comma. And then for the Y, we just want to use the current Y position. So we actually need to get the player's camera. So for now, we'll just put 0 as a placeholder. And then for the Y, or for the Z in this case, it's mapf.lerp. And like I said, assuming it's a square map, we can just say map scale, or minus map scale, sorry, comma map scale, comma lerp.y. Yeah, now we actually need to be able to use the camera's Y here, and we need on the next line to actually tell the camera to move. So to get reference to our own player's camera, we're going to do the same that we usually do. We'll save a private, and in this case we need the transform, so private transform, player camera transform. And until we get the lobby sorted, we're going to need to use the update to get this. So private void update, and we'll just say if player camera transform is not null, then we can just return. We don't need it because we've got it now. But if the camera is null, or the camera transform's null, it means we want to try getting it. And there's no guarantee for the first few frames or anything that our player actually exists. And we've got this code in quite a few other places where we need to check each frame until the player's actually ready to try and get it. And like I've said before, this will be fine once we've got a lobby, because then the player will have loaded in ages before the map's loaded. But for now, it's just a workaround. So we'll say if network client, let's import mirror, dot connection, dot identity, if that's null, then return. It means we're not ready yet. But if it is ready, then we can just say player camera transform is equal to network client dot connection dot identity dot, and let's get the RTS player script. And right now, the RTS player script doesn't know about this camera, but I think it should. So let's head into here. And let's make a reference to our camera. So I'll do it, let's say at the top here. Serialize field, private transform. We'll call it the camera transform. We'll then make a getter for it. So we'll just say public transform get camera transform returns the camera transform. If we head back to the minimap, we can now say for our player, get the camera transform. And this is a very long line, so I'm going to put some of this to the next line, like so. And now we can use it down here. So we can say instead of 0, we want to set the height to be the current height. So player camera transform dot position dot y. Final line here is to actually set the new position. So we're going to set the player camera transform dot position to be equal to the new camera position. But we also want to add in a bit of an offset, because let's say I click on the map on top of my base. I don't expect the camera to actually be above the base. I want it to have the base in camera, in shot. So we need to actually have an offset. So let's set that up here. Serialize field, private float, offset equals, let's say something like, I think -5 might do, or -6 from testing works pretty well. So I'll go down here and I'll just say plus, and this is on the Z axis. So we need to say plus new vector 3, 0, 0, offset. And now all that's left is to actually detect the clicks to then call that function. So we can use some of the things we used before. We can use the I pointer down handler. So whenever our pointer goes down on the minimap, it calls this method. So we hit control period and then implement the interface. So if we go like this, implement interface, we now get the method somewhere down here at the bottom. And we also want it for the drag handler. So I drag handler. So as we drag our cursor along the minimap, then it should also call the function. So implement the interface, it gives you these two methods. And I'd like to move them up a bit. So let's move them up here to be here. And all we want to do in both these scenarios is call move camera. So move camera and move camera. So in both these scenarios, we'll call move camera. It's when our pointer goes down on the minimap and when we drag it around the minimap. Cool, let's head back into Unity. We'll give it a second. And we need to head over to our minimap. So let's go scenes, 1, minimap display. We can actually go inside the prefab and do this. So go into 2D mode, and for some reason, we never actually applied to the prefab, so let's hit apply. And here it is. So if we go to the minimap image, where the raw image is, we want to add onto here the minimap script, drag in the rect transform, which is here. Oh, sorry, well, it's this rect transform here. And then the map scale is whatever it is in our case, which I think is 20. And then the offset is -6. That should be good. We then need to go back to the other prefab for the player and make sure that in this field for the camera transform, we drag in the camera. Then we should be able to go back to the first scene and give it a test, though we may need to tweak the map scale. So we'll have a look. So if I go and hit host, you'll see that the camera's still over here, but that's fine. I can control my WASD. We can move around the map. And then if I was to click, let's say here, we see it does move the camera around. Now, the offset is on the Z-axis, which in our case, maybe we've got the rotation wrong. If we have a look at the camera, so we can click on player, camera, and if I move left and right, it's X. If I move forward and backwards, it's Z. So that should be fine. I think we just got the map scale off. I think that's the only problem here, because if we look back in scene 01, our floor is a scale of 20. So that means it should be like -10 plus 10. So we want to go back to over here, wherever our minimap is. So go into the minimap, and we want to set this map scale to be 10 instead. And now with that, it should actually teleport us to the right position. So if I hit host again, and I click on the base, it now actually takes us to be over the base. And I can click all down here, and it takes us to the correct point. And if I was to drag, it also does the same thing. So yeah, it works pretty well. We do have a little warning saying in the scene, there are 2 audio listeners, which means that one of our cameras, well, both of our cameras probably have an audio listener, and we don't want that. So let's go to map 01, look at the minimap camera, and here we are, there's an audio listener. Let's right click and remove it. And then we're done. So yeah, that's it for this lecture. We now have camera movement working by clicking the minimap, so you can teleport to quickly look at the enemy's base and then come back to yours. It all works perfectly. And then now we can move on to make more units, tanks, import some models, and make the game just look and feel a lot better. Hope you're looking forward to that, so I'll see you in the next one. Goodbye.